All right, test. Can you guys hear me? All right, go ahead and type questions you want to go through from the previous homework in the chat, and we'll go through a few. Hey, guys. Hey, Kevin. Caden, why is it less than or equal to? Yeah, we'll talk about that today. That's really what today's lesson is what do we do with those endpoints? It's what?
It's 4. See, 10 or 6.
That's correct. Yeah, good job.
7 minus 2 equals. Yeah. I'm just going to stay near you. And I know it equals 5.
All right, let's shocking trim. I don't know what you're talking about there. 5B, awesome. I think that's Adrian. 689. All right, let's start there. 689, 5B. Go to school yesterday and get some markers and stuff. So now we're like back to what it would normally be in class. So remember, this is page 689. Or sorry, I think it's 689. And the 5 part B. So in 5, we got to show, okay, write out the first 5 terms as part A, and then we got to show it converges. So the sum from K equals 1 to infinity of negative 1 to the K over K factorial. And yeah, it's not terrifying. That zoom is terrifying. There we go. All right. Part B, we got to show that it converges. Okay, which test should we try on this one? Well, this is where the alternating series. Did we know we didn't know the ratio in theory in this section? We didn't know the ratio test, but we do know the ratio test now. So we should take a look. Besides the ratio test, we'd use the alternating series test. The alternating series test, we would have to use one of those 2 others that you got. I think somebody was asking about it last time. The algebraic ratio test or the algebraic difference test give us 2 different ways. And again, the algebraic difference test is you show that a of n plus 1 minus a of n is less than or equal to 0 when n is greater than or equal to 1. Difference you could take out. So let's just talk about that if we did it that way for a second, since apparently we've got all the time in the world. That's what we have to show. Okay, question to you. What do they have in common? Yeah, I know the ratio test, guys. I know the ratio test, but let's see if we can work it out with that. What do these two have in common? Like if you had x squared minus x, what do they have in common? Yeah, right. They both have the term of x. What do these both have in common? They both have k factorial. So you get k factorial. When you take that out, you're left with k plus 1 in the first term, minus you took out a k factorial. Well, k times, those go away. So is that going to be less than 0 for all terms? Yeah, I don't think so. Or I don't know how to prove that that's going to be less than 0 for both terms. That one fails. This one's more useful if you've got something geometric. But let's now take a look at the algebraic ratio test. The algebraic ratio test is a of n plus 1 over a of n. Oh. Seriously, people. What did I do here? Let's just pretend that didn't happen. Let's just pretend that didn't happen. Let's look at the actual series we have. I just substituted in the denominator without even thinking about the numerator, which is not very helpful to us. Let's try that again. Yeah, Adrian, thank you for pointing out my failures on the internet to everyone. So let's try this again. Pretend like I didn't even mention that. A of n less than or equal to 0. N is greater than 1, because I was like, wait a minute, that shouldn't converge, but that has to converge. All right, let's actually substitute it. So we're getting negative 1 to the n plus 1 over k plus 1 factorial minus the original, and I can put a k when it should be an n. Thank you. Okay. What's the common denominator of n plus 1 and n factorial? Right, it's n plus 1 factorial. So I'm going to multiply this one by n plus 1 over n plus 1. And let's see what I get. Okay, so I get then, and I got to show that that's less than or equal to 0. All right, so I get negative 1 to the n plus 1 over minus negative 1 to the n all over. Because if I multiply n factorial by n plus 1, I get n plus 1 factorial. That, Tay, this was the first test. It was the algebraic difference test. I just algebraically didn't do it right. Glad you all think that's funny. Okay, so then let's look at what these two terms have in common. They both have, this says n plus 1 negative 1, this says n negative 1, so let's take that out. So then what's left over? I've got negative 1, because I took all of them out except 1. And then I'm going to take all of them out. So I'm going to minus. All right. So then negative 1 to the n is going to oscillate. So then let's take a look at what happens here. I distribute. So that's going to give me negative 1 to the n. Negative 1 minus n minus 1 more over n plus 1 factorial. And what's that going to give me when I simplify? I don't feel like. I don't think this is going to lead me anywhere. Negative 1 to the n over negative 1 minus 1 is negative 2 minus n over n plus 1 factorial. Okay, is that always going to be negative? That part's going to oscillate between positive and negative. Negative 2 subtract n. Well, when n is greater than 1, this is always going to be negative. Because we're going to take negative 2 and we're going to subtract an n from it. But then that n plus 1 factorial is always going to be positive. So this fraction is always negative, but this oscillates between positive and negative, so I don't think that works. Now, let me go back to the definition real quick. Alternating series test. The two conditions that have to happen Oh, that's right, Caden. Correct. That is correct. Yeah, we take out the oscillating part. We take out the oscillating part. So yeah, then we're just left with that. That is correct. There we go. We do take out the oscillating part. That leaves us with that, which is always negative. So therefore, by the alternating series test, the sum from k equals 1 to infinity of -1 to the k over k factorial. Oh, and it absolutely does it absolutely converge? Yeah, because we took that part out. Absolutely convert. Absolutely. That's now converges. No, you've done Freckle for 13 minutes.
So tell me when I'm done.
Okay. Yes, you do remove the alternating part. Remember the two conditions. Are number one, the limit as k goes to infinity of a of k is equal to 0. Number two, a of k is non-increasing. And of course, that's looking at the series. Questions on that? Questions on that? Yeah, I don't get that one. Oh, in the picture. Ah, now I get it. All right, let's go back up. Now, that's a lot easier with the algebraic ratio test. Yeah, I agree with that one too. 699, number 8. 699, number 8. And I think that's actually going to take us into our lesson today, if I remember correctly. Does that one, testing for absolute convergence. Let me see what else I had. 5B, 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 689, yep. Yeah, let's do that one. 699, number 8. And that's probably going to take us into our new lesson today, which it's kind of odd. We learned at the start of this that the ratio test is how we test these. But then we also got to look at the endpoints, because we have to remember that ratio test fails when the limit's exactly equal to 1, which is what it usually does on the endpoints of the power series. That's actually the reason why we had to learn all those tests earlier, is we're going to use those to determine, like, at the end values, what does it do? Does it converge or diverge? So let's look at and let's actually apply that for number 8. So kind of odd. We're going to check, does it absolutely converge? Does it conditionally converge? And then we're going to, if it does, we're going to test and see if it doesn't ask us for the interval of convergence, though. It just asks us to determine if it's absolutely or conditionally. Oh, well, let's start and see where it takes us. Okay, the sum from k equals 1 to infinity of -1 to the k plus 1 over the square root of 2k plus 1. Now, question, why did we not consider an alternating series test with this one? Or should we have? Are you okay?
I think I have a cold.
I think you have a cold too. Oh, that's what AST stands for, alternating series test. Yes. Did the alternating series test. All right, so so then that's why, Kevin, you're asking about absolute convergence doesn't need this. Well, let's even look at this here real quick. The square root of 2k plus 1 is going to be approximated by the square root of k. What does the square root of k do? Yeah, it's probably going to conditionally converge, but let's pretend we didn't know that from the start. So let's look at the alternating series test first. Is the limit, if we remove this part, the limit as k goes to infinity of 1 over the square root of 2k plus 1, is that equal to 0? Yeah, is that equal to 0? Yes, it is. Yeah. Okay, and then we took the derivative of this, which I think will be the easiest one for this one. Is that always going to be negative? Well, let's take the derivative. Let's remember that it's much easier to write it as a power. And what kind of problem is taking the derivative here? Yeah, it's conditional. Yeah, but we're going to have to, we'll talk about that in just a sec. So let's take the derivative. This is a chain rule problem. So derivative of the inside first. The derivative of 2x plus 1 is 2. Multiplied by power, base, 1 less power. Is that always going to be negative? Yes, it is. That's always going to be negative. That's always going to be negative. No, 3 more minutes. Now you guys are saying the p-value. Let's take a look and see what that's. So question, is this making is the 2 and the 1 making the denominator bigger or smaller? It's making the denominator larger, which makes our fraction smaller. But let's see if we can bound this in between one. It makes our denominator larger. So it says it by the p-series. Since p is, I said the conditional converges because the p-series test is equal to 1/2. I don't think that's quite good enough. I actually think we may have to do an integral test on this one because this, this may be, this is going to be an integral test. So let's just look and see what that is. Now, I'm going to try to bound it first because, again, like I told you guys last time, the last one that I try is the integral test because usually if I can't figure it out, the integral is going to be nasty. So let's go backwards real quick and see what we've got. If I try to bound it by 1 over the square root of k, okay, question to you guys. Which one of these is going to be larger? Which one of these is going to be larger?
What do you mean?
Okay, give you a kiss on the head.
Wait, can you tell me?
What? Well, you tell me, honey, which one's larger, the one on the left or the one on the right? Go blow your nose and wash your hands.
I'll be back with you.
The answer, did the p-series then a limit in comparison? Is Kevin Barone, is that a question or a statement? Well, this checks for conditional convergence. It is absolutely convergent if the absolute value also converges. So notice how I took out the negative part. If this part converges, it in other words doesn't need the absolute value, then it's absolutely convergent. If it has to have that, then it's conditionally convergent. The statement of what they did, but they just used a p-series with a limit convert. The left is bigger, right? Now here's the problem. The left is always bigger, but the left diverges. We have to have something this is always bigger than that converges. Yeah, I think, I'm just seeing this as an integral test. So let's take the integral from where does the series start? 1 to infinity of 1 over the square root of 2k plus 1 to x plus 1 dx. Okay, then again, I like these as a power. You, of course, don't have to do that. Oops, and then I didn't write it as a power. What type of integral is this? Right, this is a u sub, so you set u equal to 2x plus 1 plus 1. So then du is equal to 2 dx. Divide both sides by 2. And sub back in. So when I sub back in, I get the integral from 1 to infinity. And let's be proper, since this is on the internet. We're going to take the limit as b goes to infinity, make it an improper. So we get u to the negative 1/2 power. And then I'm going to have a 1/2 du. Need a new sheet of paper here. So this is equal to 1/2 the limit as b goes to infinity of 1 to b, u to the negative 1/2 power du. Of course, what's the integral of u to the 1/2 power? So 1/2 the limit as b goes to infinity of u to the 1/2 divided by 1/2, evaluated from 1 to b. Good news, 1/2 divided by 1/2 is 1. So I get 2x plus 1 to the 1/2 power from 1 to infinity. What's this going to? That's not a 6, that's a b. That's not a 6, that's a b. Remember, this is an improper integral, so you got to use limit notation for it. Substitute in. At 1, we get a finite value, but at infinity, we get a diverges. So it diverges, which means that it only converges when it has the alternating part to it. If it doesn't have the alternating part, then it would diverge. So this is conditionally convergent because of that. All right, stop and check out from you guys. Questions on that one? And then I think Hannah O'Connell had one too somewhere. Hannah O'Connell. I think yours is just number 10, if I remember correctly. Yeah. All right. So then I'll wait for just a sec. Any questions on that one? To reiterate, if it has to have the negative, it conditionally converges. If the absolute value also converges, then it's absolutely convergent. Ha ha, absolutely.
Am I done?
Yep, you're done. Have fun. Love the kitty. Be nice to the kitty. Be nice to the cat. Yeah, that's not nice.
I'm gonna put it down.
All right, number 10. Hannah asked for the sum from 1 to infinity of 1 over k squared sine of pi over k. Okay, now this part may seem scary. So let's make it easier. Yes, I have a cat. I have 1 cat, 1 dog. The cat is an introvert. The dog is an extrovert. So the cat is like ready to jump out a window. He can't believe that we're home all the time now. My dog is loving it. He's waited his whole life for this. Sort of like my kids. My daughter's an extrovert. She hates not being in school because she can't see her friends. My son is an extrovert. My son is an introvert. He's been reading the entire time and like been as happy as can be. He was happy when he heard school was canceled. My daughter punched the couch. All right. If we sub in 1, sine of pi is 0. So that's our first term is 0. Then we get the sine of pi over 2. Sorry, we start at 1. So pi over 1, kind of odd. We start there. Then we get the sine of pi over 2. Sine of pi over 3, sine of pi over 6, sine of pi. Okay, so what's this going to? Kind of odd. This is getting close to 0. This is getting close to 0. Now the question is the combination of the two getting close to 0? All right, so it's not an alternating series. The sign is going to be positive for each one of these guys. What should we do? What should we do? And we did know the ratio test. We did know the root test at this point. The bad part about ratio is k plus 1 and k for this. That's tough to decide. What should we do for this one? Write some terms. Comparison from a p. Question, Kevin, what's this going to do? Is that going to make it larger or make it smaller? Is this part making when k is 1, I'll agree that it's just equal to 1 over k squared. When k is 2, or sorry, when k is 1, it's making it smaller. When k is 2, it makes it the same. But what's it doing after k equals 2? Yeah, I agree with the comparison. Okay, is this always positive, first off? Yes, it is, because this part's always positive, and then we just talked about this part always being positive. Okay, now what can we compare this to? Well, what I like to do is just remove the nasty part. Correct. Yeah, this part, when k is equal to 1, it makes it smaller. When k is equal to 2, it makes it equal. But when k is equal to 3, you're multiplying by a number that's less than 1. So this is less than 1 over k squared times the sine of pi over k. It's equal to it when k is equal to 2. It's still less than it when k is equal to 1. And let's go back to the actual definition of the comparison test for convergence. And that meets, and kind of odd, I'm going to show you the book here. The book definition is it has to be strictly less than or equal to. If this converges, and why did I write that? That's dumb. If this is to converge, it has to be less, the one we're comparing to has to be less than or equal to. So it's okay if it's equal to it for some terms, but we really want it to be less than. And then I was a total moron and wrote the exact same series again. So this is always bigger than 0 because it's either equal to 0 or positive. This is always bigger than 1 over k squared times the sine of pi over k. This converges by what test? Good job. This is adding 0 up an infinite number of times, which we know is equal to 0. So therefore, the sum from k equals 1 to infinity of 1 over k squared sine pi over k converges by, what's up? What? By the comparison test for convergence. What's up, big guy?
I did 25.
Then you need to do freckle for Mrs. Knox.
Okay.
Okay.
Then I can be done with.
Yeah, then we're going to play outside. It's going to be really nice this afternoon.
So then I have no more left?
Correct, because remember, today's your last day of school before break. Questions from all you guys? Sorry, got to be dad and teacher at the same time. Are there any questions from 8.8? I thought Kevin Barone had one. 699. I'm really looking for one that's in like 7. Or we can just pick up that last example that we did last time. Uh, 709 number 16. Yep. Okay, sorry, Kate. 709 number 16. And that's going to leave, that will 709 number 16. Is that going to find all the numbers for which the power series converges? Yes, that yeah, why is it equal to at the endpoint 16? Is 16, just to verify, 16 has ones that are equal to at the endpoint. And yeah, that's the lesson we're going to do today. It's just about what do we do at the endpoints. But again, I need more paper. All right, Miguel, go. Are you going to use the hall pass, Miguel, or?
Dad, is your class over?
No, my class is just getting started.
Just kidding.
But honey, you can't watch a movie in here because then they'll hear that. Yeah, totally do that though first.
Oh yeah. Where's the other one?
I don't know where the other one is. Look on the floor. The cat might have moved it somewhere. All right, let's look at 16. I asked a question, but nobody responded. So I guess 16, I think 16 has something to do with endpoints, if I'm correct. We got the sum from k is equal to 1 to infinity of the quantity x minus 2 to the k over k squared. What's that? Okay. Love you, honey. All right, so let's apply our ratio to our ratio test. So we will take the limit as n goes to infinity of a of n plus 1. So that's going to be x minus 2 to the k plus 1 over k plus 1 quantity squared. You've already figured out we're going to multiply by the reciprocal. So we're going to get k squared over x minus 2 to the k. My question to you guys, this converges when what happens? This converges when what happens? Give you a second to reply in the chat. When it's less than 1, what happens when it's equal to 1? That's the killer question. What happens when this is exactly equal to 1? What happens when this is exactly equal to 1? And I'm getting some issues with streaming on my part. All right, can you guys hear me again? Yeah, is the stream working? It told me on my end it was not working. Bad juju, inconclusive. All right, yeah, let's go back to work then. Yes, when it's equal to 1, it's inconclusive. So here's the bad news. We're going to take this when it is less than 1. If this gives us an area of convergence, in other words, for some numbers, we have to then go back and look at what happens when it's equal to 1, which is what's going to happen on this one. So let's do a little bit of work. We got x minus 2 to the k plus x minus 2 to the k. We can take that out to x minus 2. Now, can we do anything with this? No, but what's the limit as, why did I write n in there? K. What's the limit as k goes to infinity of those two? Limit as k goes to infinity of those two is equal to 1. So let's talk about what we got left. We've got this. This no longer has any k's in it, so let's take it out front. We've got the limit as k goes to infinity. I should have put n's in there. I'm sorry. I keep forgetting to do that this year. Can't imagine what's distracting me from that. This part right here, as k goes to infinity, this is equal to 1. So x minus 2 is less than 1. And yes, I should have had that in absolute values. Let's get a visualization. Let's get a visualization what that looks like. So the distance between x and 2 has to be less than 1. So kind of think of 2. We could go 1 to the left, or we could go 1 to the right. So in other words, the distance between x and 2 has to be less than 1. Let's put some words on this. This number right here is called our radius of convergence. So in other words, how far can we converge from? How far is called the center of our radius of convergence. And you can't see that. That's called the center of our radius of convergence. Now, here's the deal. This tells us every number in between these two it converges for. But at 3, what's 3 minus 2? That's exactly equal to 1. The test is inconclusive there. What also happens at positive 1? 1 minus 2 is equal to negative 1. Its absolute value is equal to 1. So now we have to test the endpoints. So we have to test this for two particular values of x, for x equals 3 and for x equals 1. So here's what I ask you guys. What we had in these power series is the sum of an infinite number of monomials. A polynomial was just the sum of a finite number, like we'd have x to the 4th plus 3x squared plus 2x. This is going to give us an infinite number. We're trying to find what values of x is this going to converge for, because that's going to then give us the sine, the cosine, the e to the x that we can dig out of these. When we test the endpoints, we get the numbers at the end of our radius of convergence. So we know if x is equal to 2, that this will converge. Of course it converges because this is equal to 0, and 0 divided by that's going to give us the sum of zeros. Excuse me. It's also convergent when x is equal to 2.5, because 2.5 is 1/2, and 1/2 is going to make this smaller. But at exactly 1 and exactly 3, what's going to happen to those values? So what we have to do then is this is where these become, remember I was telling you they're going to get long. We have to test two values. And here's what your AP reader is going to want to see. We're going to test x equals 1. So we're going to get the sum from k equals 1 to infinity. And I am going to write out more values. Oops, positive 1. I'm going to write out more this first time than I ever would doing it again. So we get we get 1 minus 2 to the k power. You know that 1 minus 2 is equal to negative 1. So the k from k equals 1 to infinity of negative 1 over k squared. Now, just by looking at it, does this fit the two definitions of the alternating series test? If we remove the oscillating part, are terms going to 0? Yes. Or sorry, are the terms going to 0? Yes. Is it non-increasing? Yes, because we've got k to the negative 2 power. You know its derivative is negative 2k to the negative 3. That's always negative. So this converges by the alternating series test. And yes, Kevin, I can hear you. Kevin, my biggest fan of the comparison test. This would also converge by the comparison test too. You could compare it to 0 and compare it to 1 over k squared, and it will always be less than or equal to it. So yes, this converges. Okay, so now let's go back to this other sheet of paper here real quick. We know that the x values converges between 1 and 3. Now we're asking at 1 and 3. We know it converges at 1, so we put a dot up here. It converges there, and we're going to have an equal sign underneath. The limit test gives us the bounds that it converges between. Then this is really why we had to learn every single one of these tests is then we go back and say, okay, what happens at these two? And that's really why we had to learn all these other tests. And you'll notice it's kind of odd. At the start, you kind of feel like not confident about using these tests. And then after you go to this part, it just becomes automatic of recognition of which tests you have to use. So then let's also test the other endpoint. Let's test x equals 3. I mean, if you can't see the p coming in this one, I can't help you. 3 minus 2 to the k over k squared. You guys know that's equal to the sum from k equals 1 to 1 over k squared, 1 to the k over k squared. You know that 1 to the k is always equal to 1. 1 over k squared converges by the... Okay, come on, people. Some of you live close enough to me, I could hear you say this stuff. This converges by what? Right, the p-series test. Come on, Glen Eagle. Represent, Glen Eagle. So therefore, the sum from k equals 1 to infinity of, what was our original problem? X minus 2. X minus 2 to the k over k squared converges when x is between or equal to 1 and 3. Adrian, where are you at that you can see my house from there? If you're at Domino's, that's freaking hilarious. Now, then they're also going to ask a question, what's the radius of convergence? How far from the center can you go? The radius is equal to, radius is equal to 1. Where's the center? X equals 2. All right. Whew. That's really the lesson for today, too. Where do you live? Early lunch. Guys, what do you think? I get paid the same salary no matter how many hours I put into working on online teaching? More examples, please. Oh, yeah. Somebody asked if we're going to have class on Friday. Can I say no to Friday, but maybe to spring break? I got to figure out this childcare teaching thing because I'm doing a decent job teaching, but my kids are basically watching their iPads all day. Are you getting paid? I better be. I assume I would be. I mean, the school district already got all its money from the state. Why wouldn't they pay us with it? But I don't think any of us know how this is going to work out for sure. So, okay, AP number 2 is a good example. AP number 2, yeah, we can do that, Braden. Braden, can I finish the example that we started last time? Then I'll do that for my last one today. Because I think last time Netflix stock must be flourishing. Yeah, except the stock market's not been doing well over the last few weeks in general. But I actually don't know if Netflix is publicly. For some of you all, this project is not going to teach you what I wanted it to. It's going to teach you like you lost a ton of money in the stock market. But you basically had the worst time since 1987 to be in the market. So we'll see where it ends by the end of the year. Okay, if I remember correctly, we did this one last time. K equals 0 to infinity. And we had it as K over x to the K over, I think it was 5 to the K. Can somebody verify that? It is. Let's see how it is. Can somebody verify that that is the one? Logan, it's extremely contagious, and we're trying not to overwhelm the healthcare system because the bad news is the healthcare system is already busy this time of the year because of the regular flu and because it's a bad time of year. If you add this on top of it, what's going to happen is there's going to be so many people sick that they just can't handle it, which is what's happening in Italy right now. Is like doctors are having to say, well, yeah, you need a ventilator, but we don't have one. And that's not exactly what you want to hear when you go to the hospital for something like that. So we're really doing this to just ease the burden on the healthcare system more than anything. And the flu isn't that bad, largely because we have vaccines. Just things might be different in our society, but we're trying to reduce the amount that they're going to have to deal with. Because I'm just making sure. Is this the problem we were working on? And then I think we got it down to the limit as n went to infinity of n plus 1 times x to the n plus 1 over 5 to the n plus 1 multiplied by the reciprocal 5 to the n times x to the n, and that was less than 1. All right, good. All right, and then we did that and that just gave us 5. So the limit as n goes to infinity, that and that just gives us an x power. So we took out the absolute value of x, because it didn't have anything to do with n anymore. We had inside the absolute value n plus 1 over 5n, which we know this part right here, as n goes to infinity, this goes to 1. As n goes to infinity, that goes to 1. So we had the absolute value of x times the limit as n goes to infinity of 1/5 was less than 1, which means that the absolute value of x over 5 had to be less than 1. Okay. So then multiply both sides. So the absolute value of x has to be less than 5. Okay, question to you. What is our radius of convergence, and what is the center of that the interval of convergence? What's the center of that interval of convergence? And 5. So between -5 and 5. Well, what's in the middle of there? 0 is our center. How far can we go from 0 to get our radius of convergence? Right, we can go 5 to the left or 5 to the right. So our center is at x equals 0. And our radius is 5. Now we have to test the two endpoints. So we got to substitute in 5 and -5. And you can kind of see what's going to happen when I substitute in 5. And you can kind of see what's going to happen when I substitute in -5. You're going to, a lot of these are alternating series at the end of the day. So the sum from k equals 0 to infinity of, let's test x equals -5 first. Okay. I can break this up. -5 is equal to -1k times 5 to the k. Doom, doom. Question to you guys now. Does this converge? It diverges. Why? What test? Right. It diverges by the limit, by the nth term test, because your nth is not going to go to 0. Right. So it diverges there. Let's check the other endpoint. So let's test x equals -5, or x equals +5, sorry. So we get k times 5 to the k over 5 to the k. Boom, boom. Which does what? Right, that is just k, so that diverges because you're adding up from 0 to infinity. So kind of odd. This one diverges at both endpoints. So your interval of convergence is between -5 and 5. But neither one of the endpoints converges. All right, good job, Kevin. All right. So now let me get some feedback from you guys. Do you guys want to put that in? We can formalize it a little more. We can do another example, or we can do AP2. And right, yes, so no equal signs, because when you substitute both endpoints in, because remember the ratio test only works when it's less than 1. When it's exactly equal to 1, which it would be equal to 1 at both 5 and at -5. Yes, you want some board space and a problem? All right, you can have some home board space. Let me find a good one. I think we haven't done one that, yeah, let's do this one. Okay, example. Yeah, let's go for I think this is our third example. We're going to work on this. So let's go the sum from k equals 0 to infinity. And let's go x to the k over the, what should we go for here? K plus 2 to the 2k power. All right, everybody call a partner or get a partner on text. I will give you a hint on this one. Do you think this is a good ratio test or do you think this is a good root test? Yeah, this is a good root test one because it's got a power in both. So give you a hint. This is a good root test one. Ready to go. Oh, shit. Give you like a minute or two more to work on it. And you guys can totally use the chat to talk to each other. I know it's sad you don't get to see each other. Get on your roof and wave at each other. Um, I don't know if we're going back to school, man. We'll see how this works out. I don't think I have any guess on that one. Kansas just canceled school for the rest of the year, so I think we'll see. And I'm more worried at this point on what they're going to do with AP testing. Like, I don't really have a good idea, or I'm going to check AP's website real quick. What they're going to do. The LA Times reported yesterday that they may cancel them, or they may modify them to be like at home. How that one's going to work out. So, all right, let's take a look at. I'm very curious how they would make an at-home exam, but we'll see. Yeah, we'll see. All right, let's take a look at this. Let's do a root test on it. So we're going to take the limit as n goes to infinity of the nth root of x to the n over k plus 2 to the 2n. Let me make sure I got that set up. No, don't give in. Well, Logan, I hate to break this to you, but just don't feel like that one's in the cards for you. Oh, yeah, that's what I always forget, the absolute value. And the absolute value has to be less than 1. Yes. All right, so this is pretty basic. Take the nth root, take the nth root, so we get the absolute value of x over the absolute value of k plus of n plus 2 has to be less than 1. And did I do that correct? Oh, no, we're going to have a squared in that denominator. All right, the nth root of that is that. The nth root of that is that. And don't forget, we're going to take the limit as n goes to infinity. Now, kind of odd, does this have anything to do with n's anymore? No, it doesn't. So suddenly I'm getting a 5. It'd be too easy to cheat. Nah, we'll see. Limit as n goes to infinity. This x doesn't have anything to do, so we're going to take the absolute value of x out. We've got the absolute value of 1 over n plus 2 quantity squared less than 1. As n's to infinity, where is this going to? This is going to 0, so the absolute value of x times 0 has to be less than 1. When is that true? Right, that's always true. So it doesn't matter what value of x is. This is always going to converge. Honey, just a sec. Oh, yes. Okay, gotcha. So this is always convergent. So what's our radius of convergence? Our radius is equal to infinity. Because it doesn't matter. It always converges right on. What's our radius? What's our interval of convergence? Negative infinity, less than x, less to infinity. That's just another way of saying it. Where's the center? I guess, well, the center of the universe from infinity to negative infinity is 0. So there's three different ways this could occur. A power series, and that's what I said, formalize it. A power series can converge. Well, we just did an always. That's an example of what we did up here. For certain values, when it's certain values, then we get a radius, and we typically have to test the endpoints to see if it converges at them. Or step 3, it could never converge. Imagine just real quick up here, if the n squared plus 2 is in the numerator, this is going to, as you take the limit as n goes to infinity, this is going to go to infinity. Infinity times any value of x is going to diverge, or it can never converge. In other words, it diverges for all values. And I forgot up here also, we have a center here. A center of that. Today's the Thunder time. Ha ha ha. Yeah, let me call up all the boys in senior Thunder time and let's have a Thunder time lesson today. All right, now let's go to AP2, and then I'll give you some problems to do, and then we'll call that spring break. AP number 2 was requested quite earlier, and it is. Don't forget about Cassie. Yeah. Oh yeah. Sorry. There are 3 girls in my Thunder time. I just feel bad for them. All right. So if the radius of the convergence for this series, so we're going to go from k equals 0 to infinity of a of k times the quantity x minus 3 to the k, and the radius is equal to 2. Well, that meant that we had x minus 3, its absolute value, was less than 2. Okay, so let's drop the absolute values real quick. That means this distance has to be between -2 and +2. Let's add 3 to both sides. Or actually, we'd add it to all 3 sides in this example. Okay, so now let's go through and see which of the following must be true. It doesn't say maybe. Which one must be true? Does it converge at 1? It could, but then we don't have enough information to tell that. Does it converge at 2? Yes, it does. Does it converge at 5? Maybe. We don't know for sure. And again, x minus 3, remember this is x minus the center c. So if it's centered at 3 with a radius of 2, that means we could go 2 to the left or 2 to the right of 3. So the only one that must be true is 2. And hopefully that's the answer in the back of the book. Can somebody confirm that real quick? Hey.
I finished everything.
Good job. Elbows. Questions from you guys. Otherwise, I'll give you some problems here. Nothing. Total radio silence. All right, tonight, here's what I'd like you to do. Scan your assignments in or take a picture of them, then upload them for me in this class in Schoology. I assume you guys know how to do that because you've done it for other classes. If not, I can have Dr. Watkins make a video on that bad boy. Here's what I'd like you to do tonight. Page. I'd like you to do 27 through 31. And 33, 35, 43. 40 is a good problem. And then 51, 52. All right, that's it. We'll start Taylor McLaurin series next time. We are kind of closing in or converging on the end of this chapter. What's due tonight? The homework from last time. Just scan that in, send it to me, and we'll go from there right now. Other questions? I will text this out, and have a good one, everybody. See you on the other side of spring break. Have a great break. Make a forum or something. There's no place to upload in Schoology. Let me look real quick. Somebody in my debate class figured this one out already. Oh, sorry. Hey, Ben. Oh, it's nice.
Enterprise model.
What's that? Hold on just a second, man. I'm trying to figure something out. It's out in the garage. Huh.
Okay, so
Well, how about I'll work on it. I'll text you guys out when I see it. My dog's going nuts here.